Hey everybody, how you doing? I hope today's quiz went very well for you today. Sorry, second period, for giving it to you at the end. That was rough. I hope you all had a chance to finish it, and if not, I hope you came by during lunch to get it fixed, to finish it. So with that said, I might have a couple of interruptions today. So, in the last night's lesson and in class today, we were graphing exponential equations. So today's lesson is going to be the opposite of that, which is writing equations from graphs. I put together just like just a quick little guide, cheat sheet, if you will. First of all, you're going to want to decide if you're an option 1 type person, so you consider 2 parent graphs, or an option 2 person, so you consider 1 parent graph. Then, what I normally do, I normally look at the horizontal asymptote. Wherever that horizontal asymptote, that'll give you whatever the vertical translation is. If the asymptote's at y equals 5, you know, it's going to be a vertical translation of 5, so it's going to be a plus 5 on the end. I use the 0, 1 point, the 0 of the 0, 1 point to give me the horizontal translation. Because 0, 1, if you reflect it, it's still going to be 0, 1. If you reflect it over the y-axis, it's still going to be 0, 1, or at least the 0 is still 0. If you reflect it over the x-axis, the x is still 0. If you do a vertical dilation, it's going to be multiplying by the y, so it's not going to affect the x. If you do a horizontal dilation, you're going to be multiplying by the x, but it's just a 0, so it stays 0. So then, after that, it'll go right or left. So if this 0, 1 point is at, say, 3, 1, you know that it went right 3, so you'd put an x minus 3 in the equation. So anyway, I use the 0, 1 point for the horizontal translation. Reflections. Reflections are going to be a little bit different depending if you're an option 1 or an option 2 person. If you're an option 1 person, you know, you kind of need to be used to both exponential graphs and decay graphs. So if the graph looks like this or it looks like that, there's no reflections at all. Whereas if the graph looked like this is what the growth would look like if it got reflected over the x-axis. A decay would look like that if it got reflected over the x-axis. So a couple different things you have to worry about if you're option 1, because you have the 2 different parent functions you have to worry about. So it's going to look like that or that, or it might look like that or that. So then it would, it'd be a x-axis reflection. So that's the only reflection you have to worry about. If you're more of an option 2 person, your parent graphs always start off like a growth, but then at that point you need to consider there could be an x-axis reflection, in which case the graph would look like this. There might be, let's just write x-axis reflection. There might be a y-axis reflection, in which case the graph would look like this. Basically, instead of being a growth, it would now look like a decay. That's a y-axis reflection. And then there's, of course, the double reflection, where in the double reflection it would first reflect over the y-axis to look like this. Then it would reflect over the x-axis and look like this. All right, double. So if you're going to be an option 2, you need to worry about all 3. It might look like this, it might look like this, or it might look like that. So kind of different things you have to worry about. If you're option 1, once again, you have to worry about 2 different parent functions, but then you'd only have to worry about a simple x-axis reflection. Like I said earlier, I'm not sure which one's better. It's just the way it is. And then finally, this is what confuses people about these points. To figure out the dilation, I compare what happens from the 0, 1 to the 1a point. A, why are you using the letter A? That's confusing. I understand, so let's use a numeric example. Suppose f of x equals 4 to the x. Well, in 4 to the x, I look at the 0, 1 point, and I look at the 1, 4 point. And typical 4 to the x goes over 1 and up 3. If this was 5 to the x, it would go over 1 and up 4. Interesting. So then, let's say that I had some g of x graph, and instead of being 0, 1, and 1, 4, it's 0, 1, and 5, 7. But I know that this is a 4 to the x graph. Well, in this case, it traveled 5 horizontally and 6 vertically. So that's a multiple of 5. So this is a horizontal dilation by a factor of 5. And usually goes vertically 3, but in this case went vertically 6. So that's a vertical dilation by a factor of 2, which would mean that the horizontal dilation goes inside and you do the opposite, so it's 4 to the x over 5. And then the vertical, with the vertical dilation of 2, sorry, this is tough to read. With the vertical dilation of 2, you'd have the 2 on the outside. Okay, I have 5 examples here, and I don't know how many of these examples you're going to want or need, but I have 5 examples. If I were you, I would at least do the first 3 examples. In fact, if you like to do problems ahead of me, here's number 1, pause, write it down. Here's number 2, pause, write it down. Number 3, pause, write it down. Example number 4, pause, write it down. And example number 5, pause, write it down. Okay, back to example number 1. Guess I'll work it like this. Okay, so this problem right here. Now, first, of the 3 key points that you'll normally see on the graph, get rid of the awkward one, the one that's like the fractional one, the -1 point. We're going to ignore that. This is going to be my 0, 1 point. This is going to be my 1a point. And nice, they tell me about the base. So in a base of 3, what I'm looking for the graph to do in a 3 to the x graph, I'd have the coordinate 0, 1 and the coordinate 1, 3, meaning to get from this point to this point, that's usually over 1 and up 2. All right, so going through this list that I showed you at the beginning, just 1, 2, 3, and 4. 1, the asymptote is at 0, so there's no vertical translations. I'm just going to put an X for nothing. No, that's confusing. I'm just going to put none. Number 2, use the 0 of the 0, 1 point for the horizontal translation. 1, 2, 3, 4. This coordinate has an x coordinate of 4, which means it's going right 4. Number 3, the look. I am used to the graph looking like this. It looks like that. It doesn't matter if you're option 1 or option 2 in this one. We'd all do this one the same. So there are no reflections. And then number 4, dilations. This is where it gets confusing for some people. I'm used to a 3 to the x graph going over 1 and up 2, but in this case it's going over 1 and up 4. So there's no horizontal dilation, but there is a vertical dilation by a factor of, I'm used to 2, but it's going 4, so it's a multiplier of 2. Okay, so then you're going to go ahead and get all this into your equation. It's a base of 3. A vertical dilation of 2 means it's going to be 2 times 3 to the, and then for a right 4, I'd write x minus 4. And that's it for number 1. Number 2. I'll put number, let's see, space it like this. Okay, number 2. Now, this is the one where I'm gonna do this problem 2 different ways depending if you're option 1 or an option 2 person, because I notice it's saying base of 1/2. If you're option 1 and you like to think about the 2 different graphs, I'm used to a y equals 1/2 to the x graph being a decay, so it would look like this, and you're going to use the key points of 0, 1, And you're actually not going to use the 1 point. You'd want to use the -1 point, -1 comma 2. So in my graph, I'm not going to use this point. I'm going to use this point as my 0, 1, and then this point as my -1, 2 point. Number 1, I noticed that this horizontal this asymptote is at y equals -5, so it's going down 5. 2, horizontal. My 0, 1 point is on a 0, not a concern, so it's not going left or right. Number 3, look. I am used to a decay graph having this look. None. No reflections. And then number 4, dilations. To get from this point to this point, don't worry about the negative. Just think about how far you're traveling. 0 to -1 is a distance of 1. 1 to 2 is a distance of 1. That means 1 and 1. And in this particular case, it's going over 2 and up 1. So that looks like a horizontal dilation by a factor of 2, no vertical dilations. So getting all that into the equation, it's y equals, let's see, this down 5 and horizontal dilation, the one's inside, one's outside. Horizontal dilation, that's inside stuff, so it would be x over 2, down 5, that's outside, so -5. So that's doing number 2 as if you were option 1. If you were option number 2, if you're option 2, option 2 people don't consider the base of 1/2 to the x, so we want to think a base of 2, or base of 2 to the x. So my graph would look like this, and I'd have this 0, 1 point and this 1, 2 point. And just like that, the 1/2 group, to get from this point to this point, it is over 1 and up 1. All right, just like option 1 people, this one's going down 5. Just like option 1 people, there are no horizontal translations. You'll start seeing the difference on number 3. In step 3, I'm used to my 2 to the x graph looking like this, but in this case, the 2 to the x graph looks like that. That is a y-axis reflection. And then for number 4, let's see. I'm used to over 1 up 1 for a 2 to the x graph, but in this case, it's over 2 up 1. So a horizontal dilation by a factor of 2. So I have these 3 transformations I need to fit into my graph. The y-axis reflection, that's inside the function. So I have 2. I start over. So I have y equals 2. Now here comes the exponent part. So the y-axis reflection, you'd have this negative, and then with the horizontal dilation of 2, it's divided by 2. So x over 2 minus 5. Oops. So option 1, option 2, similar amounts of work. You get slightly different looking equations, but they are mathematically equivalent. So you really want to decide if you're an option 1 or an option 2 person, and then stick with it. Number 3. Let's take a look at number 3. This one is a base of 4. So if I think about, so if it's a base of 4, that means that it's going to be the same type of graph whether you're option 1 or option 2. I consider the 0, 1 point and the 1, 4, because this is base of 4, so 4 to the x. This is over 1 and up 3. Okay, step 1. Asymptote, horizontal asymptote gives me the vertical shift, so up 1. The 0, 1 point, which in this case, here's that fractional point, so that's the trash. That's my 0, 1 point, and it's at -1, -2, -3, so left 3. Then number 3, reflections. I'm used to a 4 to the x graph looking at this, looking like this, but it looks like that. That is a x-axis reflection. And then number 4, dilations. I'm used to over 1, up 3. In this case, point to point, over 1, down 3, but don't worry about the up and the down because that's a reflection thing. The numbers are the same, 1 and 3, so there are no dilations. All right, so getting them into the equation. X-axis reflection, that's affecting the y-coordinates, so it's outside. So -4 to the x. Left 3 means that inside my equation I should have a +3. And then up 1 means outside of the function I should be adding 1. So once you get comfortable with the exponential graph, writing the equations for it's not too tricky. If you're confident at this point, you've done 3 solid examples and they're all good examples. So if you're feeling confident at this point, I don't see a point to you watching the last 2 examples, but if you love doing examples with Elliot, let's do 2 more examples. Number 4. All right, number 4 is the big graph, so I need to zoom out a little bit. Okay, I need to do this one twice for the option 1 people and the option 2 people. So option 1 first. Option 1 considers base of 1/3. So, Elliot, got to sneeze. Excuse me, everybody. All right, Elliot sneezed. So option 1. So if we doing option 1, we do consider 1/3 to the x. So that is a dk, and we worry about the point 0, 1, and -1, 3. And in this particular case, to get from 0, 1 to -1, 3, that's traveling horizontally a distance of 1, vertically a distance of 2. Going into my graph, here's the fractional points. I'm going to get rid of that. I'm going to use these 2 points. Step 1. Let's see, this horizontal asymptote, -1, -2, -3, -4, so down 4. Number 2, the 0, 1 point is still on my 0, so there's no horizontal shift. Number 3, reflections. I'm used to my graph looking like this, so there's no reflections. And number 4, dilations. I'm used to over 1, up 2, but in this particular case, this is a distance of 1, so 1, and then vertically it went from 5 all the way up to 23. That's a distance of 18. So I'm used to it going over 1, up 2, but in this case it's going over 1, up 18, so that is a vertical dilation by a factor of 9. So at the end of the day, the vertical dilation gets put out front, so 9 times 1/3 to the x. The down 4, that's always treated just adding or subtracting on the end. So 9 times 1/3x minus 4. That's doing number 4 if you're an option 1 person. If you are an option 2 person, option 2 people do not consider the 1/3 to the x in their head. They only consider 0, 1, and 1, 3. But just like the other one, this is going over 1 and up 2. Okay, so number 1, down 4, just like the previous problem. Number 2, none, because the 0, 1 point is on my 0. Number 3, reflections. Yes, reflections, because I'm used to the graph looking like this. Now it looks like that. This is a y-axis reflection. And then finally, number 4, dilation. Just like option 1, I'm used to it going over 1, up 2, but in this case it went over 1, up 18, vertical dilation by a factor of 18, which means that my equation is going to be 18 times 3 to the, that y-axis reflection. Let me let's start over. This needs to be an exponent, not a big old thing there. 18 times 3. Here comes the exponent, negative x, and then the down 4 minus 4. So option 1, option 2, slightly different looking equations, slightly different technique. I don't know which one's better, which one's easier. I think they're both good. All right, last example, example 5. And like I've said, if you're feeling confident at this point, you might not need this. I'm just trying to do as many examples as I have during my lunch hour. Okay, so in this one, we have base 2. Oh, okay, interesting. They're trying to trick you here. Base 2, that's a growth. But this is a decay. So if you do a base 2, it's going to have a y-axis reflection in it. So if because this is a decay, if you are an option 1 type person, you're going to want this to be, so if you are option 1, you want this to be a 1/2, a base 1/2 problem. Whereas if you're option 2, you're going to want to use the base 2. So if you're option 1, you will not have a y-axis reflection, whereas if you're option 2, you will. I tell you what, I'm going to do it like just as it reads. I'm going to do this as a base 2 graph. So in a base 2 graph, I am used to this situation with a 0, 1, and a 1, 2, meaning to get from this point to this point, over 1, up 1. In my graph, get rid of the fractional point. I'm going to use these two. Asymptote's at 0, so there's no vertical shift. Number 2, the 0, 1 point is on the axis, so there's none. Number 3, reflection. Well, I'm used to a base 2 looking at like this, but this one looks like this, so that's y-axis reflection. If you're doing base 1/2, there'd be no y-axis reflection, which would make that kind of nice. Number 4, dilation. I'm used to over 1, up 1. In this particular case, this is a 0.5. That's at 1, so this is a distance of 1/2. Oh, and then same thing here. It's going 0 to 1, so this is also a distance of 1/2. So, oh man, vertical dilation by a factor of 1/2, horizontal dilation by a factor of 1/2. And this was a base 2 graph, so I have y equals, put in that vertical dilation first, so 1/2 times 2 to the, there's a y-axis reflection and a horizontal, so horizontal dilation by 1/2. So if there's a horizontal dilation by 1/2, that means you're going to multiply the equation by 2, and with the y-axis reflection, you could write it like that. Or maybe 1/2 times 2 to the negative 2x. You could write it either way. Both are mathematically okay to do. I think I prefer this answer, but I understand that answer as long as you have these parentheses here. Ooh, that was a tricky problem. All right, everybody. So those were 5 examples for you. And then tomorrow in class, we're going to continue on with graphing and writing equations. And it's important to have this stuff solidified by the end of class on Wednesday, as we're starting new stuff on Thursday, I think. We're going to have a quiz on this on Friday. So I hope this is going smoothly for you, and I will talk to you on Wednesday. Have a great day. Bye-bye.